I am Srinivas Gowda, working as assistant professor in IARE College. In this session, we'll discuss the SQL entry questions part 2. In the last session, we have covered the first part. In this session, we'll consider the second part. What is a view? What is a view in a SQL or a DBMS database? Okay, a view in SQL is a virtual table based upon the result set of an SQL statement. Okay, it is a virtual table based on a result set of an SQL statement. You write select star from EMP. This is going to give you some results. Suppose there are 100 records, you get 100 records. That result set is a virtual table. When you make it as a view, you just say create view here, create view name as VW employee, VW EMP as select star from EMP. Now, when you execute this select star from VW EMP, the table's data from EMP will be displayed to the user. So it is a virtual table based on the result set of an SQL statement. The view contains rows and columns just like a real table. Okay, the view will contain columns and rows because it is a result set, and a result set will contain columns and rows. The field in the views are fields from one or more real tables in database. So that that result set can be derived from one or more tables. If there are one or more tables, by using joins, we can combine those tables by using joins and combine to get a result set. That result set, if you save to database, it will be a view. For example, here the table 1 we have table A, table 2 different tables, and writing a query or joining these two conditions, we write a query and we get this type of data. So here you see that we are getting first two columns from A. This is A, this is B, then this is BB. Then again you are getting remaining all columns from B. So this view is getting two columns from table A and remaining all the columns from table B. So now when we get a result set, this result set, if you save to the database, it will be a view. So and going forward, you will not have, suppose you don't have access to a table, but we have access to the view. Still, you can see the data in that view. So view is a virtual table. View is a virtual table based on the result set of an SQL statement. A view contains rows and columns just like a real table. The fields in the views are fields from one or more tables in the database. Next slide. What is normalization? The term normalization represents the way of organizing structured data in the database efficiently. It includes the creation of tables, establishing relationship between them, and defining rules for those relations. Inconsistency and redundancy can be kept in check based on these rules, hence adding to the flexibility of the database. So the normalization is your data is carried in multiple tables. Instead of having data all in one table, you are going to break your data based on the relations into multiple tables. When you break into multiple tables, and if you need to get back the data, we will be joining all these tables to get the required data. So normalization is a part of storing the data efficiently. Okay, and by the normalization, you are going to remove the inconsistency and redundancy of the data. So again, in the normalization, we have first normal form, second normal form, 3 normal form, or next to 3.5 normal form. Okay, so you are able to achieve up to 3.5 normal form or boys code normal form. That means your data is in good shape. Okay, that is the normalization. Next, what is denormalization? Denormalization is exact opposite to the normalization, where the normalized schema is converted into a schema which has redundant information. The performance is improved by using redundancy and keeping the redundant data consistent. Consistent. The reason for performing the denomination is the overheads produced in the query processor by an over normalized form. Okay, so denomination is nothing but opposite to the normalization, where in the normalization your data is scattered into multiple tables, by which you're able to remove the inconsistency redundancy. But in the opposite process, your entire data is one table, so it is going to have redundancy and inconsistency. But the performance is that if you want to get the data, you can get it, or you can get it from only one table instead of joining multiple tables. So as it is only single table, your data will be coming faster. But however, there is a chance of that your data is inconsistent state, or there is some duplicates are there. So denomination is generally used for reporting purposes, but it is not advisable to have to get the reports getting from the denominalized data, because it might have redundancy data, and also there might be inconsistency. Okay, now we'll see what are the various forms of normalization. So we know that normalization is that to divide tables into to tables to distribute data into multiple tables. So normalization forms are used to eliminate or reduce the redundancy in database tables. The different forms are as follows. First, we will see the first normal form. A relation is in first normal form if every attribute in that relation is a single valued attribute. Means it should be always a single value attribute. Now, this is the keyword here. In the first normal form, we'll be talking about single valued attribute. If a relation contains composite or multi-valued attributes, it violates the first normal form. So consider following student example. Each student in a table will have a name, his or her address, and the books they issued from the public library. So student name is Sarah, address is this, and she has taken two books here. Two books. Okay, she is Miss. Okay, now this is a multi-valued attribute. See, for one student you have two books. Now this is a bad design. This is a bad design, because Sarah is taking two books here, and there's one more Sarah, who was taking in two books. So this is the first normal form. It is not in good form. Now we'll convert this into first normal form, and that means it should have a single valued attribute. So how we are going to correct it? As you can observe that the book she issued field has more than one value per record, and to convert it to first normal form, this has to be resolved into separate individual records for each book issued. So here we had multiple books taken by a student. Now in the first normal form, we have to have a single valued attribute. That means each book issued should be a separate row. So in the first normal form, so what we are doing is, in the first normal form, each book will be a single row. So earlier Sarah has taken two books, and these two are part of one record. Now we are make it as two, first record and second record. So, and similarly, all the rows are having only single book instead of multiple books. So this is the first normal form. In the first normal form, it is single valued attribute. Single valued attribute. Every row should be unique. Every row should be unique, and there should not be any duplicates. Now we'll see the second form. After completing the first normal form, in order to implement the second normal form, you also have to first implement first normal form. So we'll see the second normal form. A relation is in second normal form if it satisfies the condition for the first normal form. So this is mandatory. It should satisfy the first normal form and does not contain any partial dependencies. There should not be any partial dependencies. In the first normal form, it is single valid attribute. Single valid attribute in second normal form, it should not have no partial dependencies. For example, it has no non-prime attributes that depends on any proper subset of any candidate key of the table, often specifying a single column primary key is a solution to the problem. So how we are going to, that means they should not be, it should have non-primary attributes that depends on any proper subset of any candidate key. So what is a candidate key? A group of columns identifying the record uniquely. So by making a single column primary key, by that we can remove the partial dependencies. For example, consider the following example. As you can observe, student table in the first normal form as a candidate key in the form of student and address. Student and address. Student and address. Okay, as a candidate key in the form of student and address that can uniquely identify all the records in the table. You cannot have only student as a primary key because there are two Saras here. There are two Saras here and they both stay in different locations. So the combination of Sara, the combination of student and the address can be made as a primary key. Can be made as a primary key. So because these two combination can uniquely identify a record. Can you identify a record? The field books issued, issued a non-prime attribute primarily depends partially on the student field, as the table is in second normal form, is not in second normal form. To convert into second normal form, we'll partition the tables into two by specifying a new primary attribute to identify the individual record in the student table. A foreign key constant will be set on other table to ensure referential integrity. So if you see here, the combination of student and the address is the primary key. So this way I will have primary key here, and we'll have one more table, books issued. In that we'll have a foreign key relation to maintain differential integrity. Now we'll convert this table into second normal form. So in that case, so what we did is that in the first table we had the students and the address and his details. So in the second table we have student ID, and it has the books issued. This is the second normal form. See, student ID is a student ID 1, 2, 3, 4. Okay, the combination of student ID can be made a primary key, or the student plus address can be made a primary key. In this case, as the student ID is unique, I am making this as a primary key. I'll use this in the second table. I'll use in the second table as a foreign key relation. So here I can say now if I want to know the books taken by the person 3, so I can get directly by joining these two tables. Now this is the second normal form. A third normal in the second normal form, there should not be no partial dependencies. The third normal form, a relation is said to be in third normal form if it satisfies the condition of second normal form, and also there is no transitive dependencies between the non-prime attributes. In the second normal form, there should not be any partial dependencies. In the third, there should be no transitive dependence between the non-prime attributes. All non-prime attributes are determined by the candidate, are determined only by the candidate key of the relation, not by any other non-prime attribute. So now we consider the example. We consider the example in the example. We can do a student table. The second normal form has a single candidate key called student ID, and it can uniquely identify all the records. It can identify all the. This is the single candidate. This can as a primary. Okay. As you can observe, the student table is the second normal form, has a single candidate key, student ID, primary key, that can uniquely identify all the records in the table. The field selection non-prime attribute, however, depends on the student field. See, this is depending on the student field. This is depending on the student field. So that is a transitive dependency. That is a transitive dependency. So what he says is the field selection Solution, however, depends on the student field rather than candidate key. Hence, the table is not in third normal form. To convert into third normal form, we'll once again once again partition the tables into two while specifying a new foreign key constraint to identify the solution for the individual records. Then the student table. A primary key constraint for the same will be set on the solution key to identify each record uniquely. Now we'll see the third normal. So we'll have a different table for the for the for the solution. Here we'll have a master table for solution, like for MS it is 1, for Miss it is 2, for Mrs. like this we'll have on table, and we'll have that as a foreign key in this table to point to the each student information. Now this is in the third normal form. So the third normal form. This is the first table, student ID and books issued, and also this is the solution ID. So this will be the table after third normal form. After third normal form, we'll go to the Boyce chord normal form, also called as 3.5 form. A relation is in Boyce chord normal form if it satisfies the condition of the third normal form, and also every functional dependency left side is a super key. In other words, a relation is in BCNF has no trivial functional dependencies in the form of X determines Y. So X is a super key. Now here when I say X arrow Y, it means X that Y is determined by the value of X. Now here X is the super key. For example, in the above example, student ID serves as a sole unique identifier for the student table and the solution ID for the solution table. Thus, this table exists in the BCNF, and same cannot be said for books table, as there can be there can be several books with the same common name and same student ID. Okay, that is, if you are able to achieve up to 3.5, if you are able to achieve up to 3.5 normal form, then you are good. Next, we'll see next question. What are the truncate, delete, and drop commands? So we have here three commands given to us: truncate, delete, and drop. Okay. In the delete, you can delete one or more records. If you use a where condition, based on the satisfying condition, some data is deleted. If you don't give the where clause, all the data will be deleted. So delete from candidates. From candidates key, you want to delete where the candidate is greater than 1000. So all those records which satisfy this condition, where candidate ID greater than 1000 will be deleted. Okay, and if you don't give the where clause, this is going to delete all the rows from the candidate key. So similarly, we have a truncate command is used to remove all the rows from the table and free the space containing the table. In this case, your space is not released to the OS. In this case, your space is released to the OS. Now, if you don't give a where clause here, truncate no where clause, then delete is equal to truncate. So truncate is a command to remove all the content of the table, all the content. There will be no data at all. And next we have the drop command. The drop command is used to remove an object. From the database. If you drop a table, all the rows in the table will be deleted, and the structure is also removed from the database. When you use a delete and a truncate, your data is lost, but the structure remains. The structure of the object remains. But when you use a drop syntax, your structure is removed. That means you can no longer access the object. So drop command is drop table name, drop procedure name, drop view name. Like this is the commands. Now we'll see what is the difference between drop and truncate. So we know that drop is to remove the structure. Truncate is used to empty the content of a table. So if a table is dropped, all the things associated with the tables are dropped as well. Means when you drop a table, if there are any primary keys, if there are any foreign keys, if there are any indexes, everything is dropped. That includes the relationships defined in a table with other tables, the integrity checks and constraints, access privileges, and other grants the table has. To create and use the table once again in the original form, all these relations, check constraints, privilege and relation has to be redefined. However, if a table is truncated, none of the above problems exist, and table retains the original structure. Only thing in truncate, only data is lost, but structure remains. All your relations may exist. Okay, that is the drop and drop and drop and truncate. Now, what is the difference between the delete and truncate? So we know that truncate is to remove all the content of the data, and it's free of the space, and delete is also remove based upon where condition. If you don't have where condition, enter data is lost. So no where clause delete is equal to truncate. Okay, the truncate state command is used to remove all the rows from the table and free the space in containing the table. The delete command deletes only the rows from the table based on a condition given in the where clause, or deletes all the rows when there is no where condition is specified. If it does not space containing the table. Once you issue the delete statement, the amount of space occupied by those columns by rows will not be released to the OS. Now we'll see what are the aggregate and scalar functions. Okay. What are the aggregate and scalar functions? An aggregate, what is an aggregate functions? It performs operation on a collection of values to return a single scalar values. An aggregate function performs operations on a collection of values to return a single scalar value. Aggregate functions often used with the group by and having clause of a select statement, following other widely used aggregate functions. So to calculate the average, we use a average function. That means we have some set of data, numerical data. When you want to calculate average, it is it is summing of the data divided by the number of records is going to average. So a AVG function is an average function. Next we have the count function. Count functions will tell you how many records are available in a table or a view. Count star, count star, count star, or count of column name. So this is going to give you the number of records in the database. Similarly, we have min. So the min of values. Suppose you have a marks, you want to get the minimum marks obtained in the class. You have to use the min function, min of marks from the student table. Similarly, to calculate the maximum, we have to use the max function. So calculate the maximum values of the collection of values. Then we also have the sum function to calculate. Sum is to count it is the sum of all the values in the table. Is the sum functions. Then the first function fetches the first element in the collection of values. Suppose first or the top. Suppose you have 100 records. If you want to get the first record, then use either first or top function also. Then we have a len function. Len function is to calculate the length of the characters in a string. So length calculates the total length of the given field. So length is generally used to calculate the number of characters available in the string. Then we have U case. It converts all into upper cases. Similarly, we have L case to convert all lower cases. Then we have a mid function. Mid function extracts a substring from collection of string of values in a table. So by using the mid function, you can extract the substrings from a collection of strings in an object. Next function is concatenates, combining two or more strings. If you want to combine two or more strings, you can use concat A and B. So the columns of A and B will be concatenated to display data of A and B into one column. That is the concat. We also have the rand function or the random functions to give you a given random number, and we have the round functions. So calculates the round of integer value for a numerical field. Now it returns the current date and time. If you want to get the current date and time of a system, then we have to use the now functions, and we have the format functions. By these format functions, you can set. Suppose you want to display your date in DD, and YY. We have to use the date format, because by default your date is stored like this: 2021 07 016. If you want to retrieve this date in this format, like 07 16 hyphen 2021, we have to use the format functions. That means we have to format the data to display into our the desired way. Okay, now what is an user-defined functions and what are its types? So what is a user-defined functions? These are special routines in SQL in database, like procedures, procedures. We also have functions and triggers. All these are the programmable objects in database. So the user-defined function in SQL are like functions in any other programming language that accepts parameters, perform complex calculations, and return a value. Function is going to give you always a value. Function will return a value. It takes some input parameters and does the processing logic in what we want to write, and returns the value. These are written to use the logic repeatedly whenever required. Okay, so why a function are basically if you're writing the same logic every time, you're writing the logic every time, you write into functions and you call that functions. So again, the functions are of two types. Either function are scalar and table valued functions. In the scalar functions, it is going to return you a single scalar value. The scalar function is going to give you a single scalar value, whereas the table valued functions will return you a table as output. Advance select star from EMP is going to give result set. Same way, your function might return a table. That table will contain data. So again, we have inline table value functions. It is a table data, data type based on a single select statement, and multi-statement returns as a tabular result set. But unlike inline, multiple statements can also be used within a function body. So inline will give you a table data type with a single cell statement, whereas multi-statement will give you a tabular result set, but with the multiple cell statements. Okay, what is correlation and what are types of correlation sensitivity? So correlation is something related to your geographical settings. Okay, correlation refers to a set of rules that determine how data is stored and sorted. Suppose you want to store data into Chinese language or Japanese language, so we have to store it in their own regional languages. So the correlation is to mention in what language you want to think. There are also other conditions. Okay, these are a set of rules to determine how data is sorted and compared. Rules defining the correct character sequence are used to sort the character data. It incorporates option for specifying the case sensitive, accent marks, kana character types, and character width. Following are the different types of correlation sensitivity. Suppose case sensitive means A, R, and A, small a, capital A are differently. If you make a accent sensitivity A and this A are separately. Kana sensitivity means Japanese kana characters hiragana and katakana are treated differently. Width sensitivity. Some character represent single bytes, half width, some in double byte. So these are all properties of the correlation. So based on the correlation, your data is stored. By default, we will be using Latin. I think it is Latin English. What is a store procedure? What is a store procedure? Store procedure is also a type of programming object. It takes some parameters and it does the logic, and it might not give you a might not give a return statement. So a store procedure is a subroutine available. The subroutine available into application that access a relational database management system. Such procedures are stored in the database data dictionary. The disadvantage of store procedure is that it can be executed nowhere except in the database, and it occupies more memory in the database server. It also provides a sense of security and functionality, and as users who cannot access directly can be granted access by store procedures. There is a logic to what you want to write. You'll write it in store to the database store procedures and give that store to end users. So those who are not having access to the tables can use the store procedures to access the data. For example, here I am creating a procedure called as create procedure fetch all students. I want to fetch all the student data. I'm saying begin and end. In the between the line, select star from my student data. So student data I want to fetch. Okay, actually I can write directly the statement select star from my student data. I'm going to get the data. Suppose my end users are not having access to this my student table because due to security reasons, I don't want to give them access to the student data. I want to give access to fetch all the students. If I execute this, they are going to get output. So user execute the store procedure, he gets the data. So user executes the store procedure, he gets the data. But the same user, he cannot directly access the table. Okay, he cannot directly access the table. Okay, now we'll see what is a recursive store procedure. Recursive means it keeps on executing till it finds an end loop. A store procedure which call itself until a boundary condition is reached is called a recursive stored procedure. The recursive function helps the programmers to deploy the same set of code several times as and required. Some SQL programming languages limit the recursion depth to prevent an infinite loop of procedures called by using Stack Overflow, which slows down the system and may lead to a system. Suppose if there's no ending loop, the procedure will keep on running. By this, your system memory is entire thing will be used, and system will crash due to the lack of memory. Now we'll see an example here. Create procedure. Procedure name is calculate dot. Here I'm taking two parameters. One is the input parameter. I'm passing an in number. Out is the is one more output variable. In is the input variable. Out is the output variable. So I'm begin saying as begin. I'm saying select score. Okay, select score as a variable. Declare score as a variable. Default null. Just select my logic is select awards into achievement. Select awards from achievements where ID is equal to your score. The score is null, make it 0. If not, continue. Continue how you increase by 1. By increase 1. And you make it total is equal to total plus score. Now this now what will happen? It will only terminate when your score is null. When the score is null, it will terminate. Otherwise, it will keep on calculating. It will keep on calculating. Okay. How to create empty tables with the same structure as another tables. Okay. How to create a same by using into command. By using into command, you can create a structure of existing table. Now here I am saying that select star into student copy. This is a new table name. This table must not be existing database. from the student is existing table. I'll introduce some where condition, a false condition, 1 is equal to 1 is not equal to 2. That means the content of students will not be copied. Only the structure is copied. If I remove this where clause, I make it as 1 is equal to 1, then entire student copy of data is inserted into student copy database. So creating empty tables within the same structure can be done smartly by fetching the records of one table into new table by using into operator, while fixing a where clause to be false for all records. And SQL Server prepares a new table with a duplicate structure to accept the fetched records. Or since no records get fetched due to the where clause action, nothing inside new tables. Only if you introduce a false condition, you will have only blank, empty table, no with no data. What is pattern matching? Suppose you don't know the exact value in the database. You know that my name is the name of the student is something like Avinash, or it could be Amit. So I only know that it starts with A. If I know that student name, I can say name is equal to Amit. If I don't know the correct exact name, I'll say name like starting with A. So like operator, A percentage single quote, A percentage single quote. So is like is a pattern matching in SQL Server. SQL Server pattern matching provides a pattern such in a data. We have no clue of what exact word should be. The kind of SQL query uses wildcat to match the string pattern rather than writing the exact word. The like operator is used in conjunction with SQL wildcards to fetch the required information. So using the percentile to use a simple search. The percentile wildcard matches 0 or more characters of any type can be used to define wildcards both before and after pattern. So such a student in a database whose first name begins with letter K. So I'll say first name like K. Now all the students whose first name starts with K will be listed like Kumar, Kirti, like etc. Now omitting the pattern by using the not keyword. By using the not keyword to select records that does not match the pattern. Suppose you don't want to retrieve the students whose name starts with K, just say not like. Just say not like. Now pattern matching using the percentile wildcard search. So search for a student where she has letter K in his name or not. So percentage K or Q percentage means anywhere in your name, if the Q is there, it's going to get the data. Okay, using the underscore wildcard to match pattern at a specific portion. The underscore wildcard matches exactly one cat of any types. This can be used in conjunction with the percentile wildcard. The query fetches all students with the letter K and letter K, and K is at the third position. So K second or third position. So first can be anything, second can be anything, third should be K, and after that can be anything. So pattern matching, in DBMS is percentile and also underscore. Underscore is for searching for a single occurrence, single thing, whereas percentile is used for multiple things. Okay, now pattern matching for specified length. So the underscore is also used for one characters. So here matches first name with three or more characters. So it's 4 characters. So there will be four underscores here. Now index. Now you see the index. An index is a database object which can be used to create one or more columns. An index column contains the store in the form of B tree and enables SQL Server to find the rows or rows associated with that key possible. So basically, it's like pointer. It is like a pointer in your book. If you go to the end of the book, you see that the appendix. You see that at this page, this is located. So the index is like a pointer. So that when you query the database, you'll get the data a little faster. Okay. and we have something clustered, non-clustered. A cluster index reorders the way the records in the table are physically stored. Therefore, the table can be have only one cluster index. The leaf node of a cluster index contains the data pages. So here, my table ID 1, 2, 3 is 8 records I have. So the index is stored in the form of a B structure. So like 2 to the power of 0 is 1. Similarly, 2 to the power of 1 is 2. 2 to the power of 2 is 4. Then we have a non-clustered index. Is an index in which the logical order of the index does not match the physically sorted order of the row in the disk. The leaf node of a non-clustered index does not consider data pages, whereas your clustered printer will consider data pages. Instead, the leaf nodes contain index rows. A table can have more than one clustered index. Where the index of a book is the perfect example of a non-clustered index. Thank you. With this, we complete the SQL entry questions part 2.
Like, share and subscribe. Hit the bell icon for more updates.